So this is your 2, 3 notes. It's on supply and demand, which I think are kind of words you're used to. Your learning targets are going to be, you are hoping that by the end of this video you can calculate retail price, interpret the supply and demand curves when they're given to you, and then calculate demand functions given a table of data. That last one is really, really similar to something you've already done in 2.2, finding a line of best fit. It's just with different data. It's with data on supply and demand instead of random things. Okay, so for your vocabulary, your first word is widget. I used to just think that was some funny thing that our books, like our math books, would use. It's a real thing. So a widget is name economists give new, unnamed products. So it's what? Economists call new, unnamed products. A function we talked about in class. We talked about thinking about it as a vending machine, right? A functioning vending machine. When you hit a button, you know what you're going to get every single time. So you know every single time you put a certain x value into this function, into this equation, you know what you're going to get for a y value. Things that are not a function would be when you put in an x value, you could get 2 or more different y values. So the math definition of a function is a rule. Usually it's an equation. It's always an equation for you guys. That assigns each x value oh gosh, I cannot. I'm struggling, huh? To only one y. Alright, so for a demand function, I'm going to get rid of this stuff so we have more space. Hopefully I can write neater if it goes up a little bit higher on there. Alright, a demand function. You just learned what a function was. So a demand function is the quantity consumers want. Quantity, so quantity is how many consumers, the people buying it, want. It usually decreases, so demand usually goes down as price goes up. Right? If something is super, super expensive, if the price is going up, not as many people are going to be able to or want to spend that price for it. So demand, sorry, I made a mistake. This is your demand. I'm going to flip-flop these. Your demand function. Sorry, I should have those things flipped in your notes. It's bothering me. The demand function will go here. So your demand function relates the quantity I will fix that for next year. The quantity to its price. Okay, supply, the quantity of items available to be sold. wholesale price. You might hear sometimes if somebody works for a certain company, they get to have their products at wholesale price. So the wholesale price is the price the manufacturer charges. So if you are the owner of like a Walmart store, the people that make the shoes that you are selling will sell them to you at wholesale price. You will then give those things a markup, and that will make it the retail price, what you sell it to the everyday person for. So a markup is the amount retailers increase the price so they can make a profit. Your retail price is the price that the retailer sells the product for. It's what you and I would go to the store and buy it for. Okay, so we have one more. And it's equilibrium. To me, equilibrium sounds a lot like equal, right? Someone in class mentioned talking about it in science class. That would make sense as well. Alright, so equilibrium is the point of intersection. Oops, I'm sorry. Of supply and demand functions. Okay, that's our last one. So we'll get rid of that, and then we'll start the example. Okay, so if you remember, your first learning target or learning objective was to calculate retail price. So your first example tells you how to calculate retail price. This is when your markup is just a money amount. They straight out give it to you. Example 2 is for that same learning objective or learning target, still calculating retail price, but it's when your markup is a percent. Okay, two kind of different ways they could ask that same question. Alright, so if your markup is just a given money amount, so it says the Wacky Widget Company sells widgets for $2 each wholesale. Remember that wholesale means what the manufacturer, whoever's making these things, is going to sell it for. So it's what the big store is going to buy it for. So if your wholesale is $2, and then this local store has a markup of $1.59. So, and they want to know what the retail price, what you and I would pay for at the store. So the store's paying $2 for each of these widgets. They're doing a markup of $1.59, so I'm going to add $1.59 to the price. And that's what they're selling them to you and me for. That's what they're getting for a retail price. So $2 and $1.59, that would be $3.59. That's your answer. That's all you have to do. Okay? To kind of recap what we just did, we took the wholesale price, right? We added the markup, and we got retail. Why I did that is because that's going to help us down here. They're starting to ask abstractly, right? They're not giving you numbers, they're asking you do it algebraically. So the wholesale price of an item is X dollars. Well, up here we took the wholesale price and we added the markup to it. So let's see what happens. The wholesale price is X dollars. So I'm going to write that down. That's my wholesale price. The retail price is R dollars. Okay, well, we did this and we got retail. Express the markup algebraically. Okay, well, my markup I had to add here, right? So they want us to express the markup. So how would I have gotten just the markup with these two numbers, the $2 and the $3.59? How would you have found the markup? So you can either do this algebraically, you could subtract x from both sides and have what m equals. Or if you just think up here in terms of numbers, if they told me that the retail price was $3.59 and the store originally bought the product for $2, I would have to subtract the $2 from the $3.59 to get the markup, to get what the store did to the price to make a profit. So I would take my retail price and I would subtract my wholesale price, and that would give me my markup price. If you did it over here, you just subtract x from both sides, and you'd have r minus x, which is what you end up with here. That's your answer, just r minus x. So make sure you're paying attention kind of where those things are and what their definitions are to decide if you're going to add or subtract. Alright, so the next one that we're going to do is just talking about the same idea, only instead of just monetary amounts, we have to use a percentage. So it's going to add an extra step. So it says the Robert Corporation sells teddy bears at a wholesale price of $23. If a store marks this up 110%, what is the retail price? If they're marking it up over 100%, this price has to double. It's going to more than double. Okay? So I first have to find out what the markup would be. I have to figure out what 110% of the wholesale price would be. So remember, to make a percent into a decimal, I'm going to move the decimal spot, which is right there, over twice. So it will be 1.10 as a decimal. And then need to multiply that by the wholesale price. Remember, this is all to get the markup. Okay, everything I'll do in blue is to get the markup price. Above, you were given the markup price. So it's 110% of $23. So it's 1.10 times 23. If you do that out, you should get $25.30. So that means the store is making a profit of $25.30 every time they sell one of these bears. That's their markup. If you remember above, we just took our markup and we added it to our wholesale price to get our retail price. So everything in blue was your markup. Now I'll figure out the actual answer to the question. I'll actually figure out the retail. So retail price is my wholesale price of $23 plus my markup of $25.30. And that will give me a total of $28.30 for retail. Oh, excuse me, $48. Can't add 2 and 2 evidently. $48.30 to get your retail price. Okay, really similar problem below. A banner company sells 5-foot banners to retailers for X dollars. The St. James sign shop marks them up 90%. Express the retail price of St. James store algebraically. So above, to get our markup, right, we did that in blue, we had to change this 90% to a decimal, so it's 0.9. And then we had to multiply that by the wholesale price. Here, the wholesale price is going to be X dollars, right? It's what the company sells to the retailers for. So it isn't what the retailers sell it for, it's what they buy it for. We need to multiply that by X. This is your markup. Above, once we had found our markup, to get our retail price, we just added the markup to the wholesale price. So in this problem, my wholesale price is X. My markup is 0.9X. If you want to leave it like that, that's fine. I would love it if you remembered that there's a 1 in front of that X. So 1 whole plus 0.9 would get me 1.9X. I can put those together because they're like terms that I'm adding. Okay, there's my retail price. All right, so there's 2 different ways you can calculate the retail price, right? That was your first learning objective, calculate the retail price. Your second learning objective is to interpret the supply and demand curves. So here we go, interpret the supply and demand curves. So the first one says, the graph shows the supply and demand curves for a widget. Remember, a widget's just what they'll call some unnamed product. What is the equilibrium price? Remember, equilibrium is where the functions of supply and demand intersect. It's where they meet. So here's my supply curve, here's my demand curve. Where they meet is right there. If I'm looking for price, they have done price down here and quantity here. So my price is $11. Okay, at $11, my supply and demand will be perfectly matched. Then it says, explain what happens if the price is set at $9. So $9 is like down here somewhere, right? So what will happen at $9 to the supply and to the demand? Do you agree that at $9, your supply, which is right here, will be less than your demand? Here's your demand way up here, right? People will be wanting more of these things at $9 than have been supplied, that have been made, that are out there. So at $9 supply is less than demand. Okay? So if that is happening, if there are less of those things out there that people want, suppliers are going to try and increase the price. Okay? If everybody wants one, and like if 20 people want one and there's only 10 of those products, they can charge more for that number of products. People are willing to pay more. So here it says, use the graph to explain what happens if the price is set at 15. So 15 is on the other side of that equilibrium price, right? Here's the 15. So at 15, supply, right? There's my supply curve. Supply is greater than my demand. Supply is greater than demand. So think about what that's going to do to the market. Right? What are the people making these things going to do if the supply, if they have more of them out there, is greater than demand? If there's 20 of them out there and only 5 people want them, what do you think is going to happen? Like when something goes on sale, right? Suppliers, the people making these things, or selling them, will lower the price. Right? Everything will go on sale, hoping to sell more. Right? They don't want to keep things that they've put money into and not make anything. Okay? So there you go. There's your second learning target. Your third learning target is going to do a very similar thing to something you've already done. So I'm going to kind of skip some steps. If you have other questions, I will happily make another video showing you how I got all of this. But it's just going to go into Desmos, put the data in, and then read the M and the B from Desmos. That's it. So here it says a company wants to base the price of its products on demand for the product, as well as on expenses. Well, yeah, that makes sense, right? It takes a poll of several of its current retailers to find out how many widgets they'd buy at different wholesale prices. The results are shown in the table. The company wants to use a linear regression to create a demand function. What's the equation of the demand function? Round the slope and y-intercept to the nearest hundredth. All right, so I just put this data into Desmos, right? My wholesale price were my X's, my quantity retailers would purchase were my Y's, and then I went and I just read the demand function. I read, once I put in y equals mx plus b, I grabbed the slope and I grabbed the y-intercept. So for this, it's going to be Q equals negative 1,756.19 P. I'm going to tell you why those letters are there in just 1 second. Plus 30,238.82. Okay, so see up here how it has a little P? And remember how we said that the wholesale price, was going to be my X? Oops, sorry, I was holding the eraser button. Okay, so I really like to think of things in terms of X and Y because my brain is so hardwired for that. But they're putting it more in context, which will be helpful later on when I actually have to do something with this equation. So on Desmos, it was X and Y. In terms of this equation, X becomes the P, the wholesale price, and Q, the Y becomes Q, the quantity retailers would purchase. So this is saying the quantity the retailers would purchase is going to be this crazy number times the price that we're going to set it at, plus $30,238. Okay? So down here it says, using the context of the problem, explain why the demand function has a negative slope. So we're going to think of this slope. Remember, your slope is the change in y, so for us, the quantity, divided by the change in the wholesale price. So this is saying that the quantity retailers would purchase is going to go down by over 1,000 if I increase the price. So that would make sense, right? If the price is going really super high, people aren't going to buy as many. That's why that negative sign is there. So down here, as price goes up, the number bought, or the quantity, goes down. Right? We said, just kind of as an aside, we said it would be quantity over price. So what this is saying, as price increases, the quantity will decrease. If you have two numbers being divided and they're different signs, your final answer will be a negative. If you're a picture person, if you like graphs, here's a graph. I'm going to do it over here so I have room. Price is my X, so here's price. Here's my quantity. So they're saying as the price goes up, right, as price gets bigger and bigger and bigger, as price goes this way, the number bought goes down. So it would look like this. A linear regression. So that would be a negative slope as well. Alright, so now you can calculate the demand function. You can do that last learning target up above. Alright, so your homework is right here. Okay, number 8, you are going to need Desmos to be able to come up with that equation. And remember, if you need help with that, please let me know and I'll make sure to do another video on how to do it specifically.